Hey everyone, how's it going? Welcome to another tutorial video. As you can tell from the title, we're going to be looking at how to merge two sprites together into one. Now you might look at that and think GameMaker probably does that already, right? There's got to be some built-in function that takes sprite A and sprite B and combines them into new sprite C, and then you can use that. However, everything that I looked online seemed to indicate that that's not possible. So I figured out a solution that I'm going to be sharing with you guys today. But if this happens to be a thing, please let me know, because I would love to have an easier way to do this. So the first thing I need to say before we jump into this video is that this video is built on the expectation that you understand surfaces and buffers. You don't have to consider yourself an expert, but I would just say be familiar with their basic concepts before going into this video, because that's how we accomplish this technique. We use a series of surfaces and buffers to convert our sprites into data. Then we combine the data, spit it back out into a buffer, or spit that buffer back out into a sprite, and then do all of our drawing there. So that being said, let's get started. So the first thing I'm going to show off here is our steps list, right? So I've broken down what we're going to do today in about 6 steps. Let's go ahead and create a new project, and we're going to go to GameMaker language. Let's just call this one merge sprites. So the first thing we want to do, let's create some sprites. So we're going to say SPR circle, and resize these to 32 by 32. And let's just make this one blue. Great. Let's go ahead and duplicate this to SPR square. And we are going to delete that and just dump this as a red square. Okay, so we have 2 sprites. There we go. Let's go ahead and set up our room. Just rename this to room main. And I'm going to come in here and just shrink this room a little bit. We don't need to work with such a huge space, so I'm going to just make it a little bit smaller. Okay, so now we have our room set up. We have some sprites. Let's create a couple objects. So I'm going to say obj circle, and let's give this the circle sprite. And we're going to create another object called obj square and give this the square sprite. All right, and then we're going to create one more object. We're going to call this obj merge, and this is going to be our merge controller. So we can actually rename it merge controller. All right, so let's come into our room and let's put everything in here. So let's put our merge controller, let's put our circle, our square, and let's create one more object. I'm going to call this one merged. So we're going to merge sprite circle and merge sprite square, and we're going to merge those into one sprite, and then we're going to assign that to obj merge so that an object will have our sprite. And just for the sake of emphasizing, let's just give this merged object some basic movement code. So that way we can see that this new object has fully inherited the merged sprites. So I'm going to say just some basic keyboard controls here. Okay, great. So now when we just move our keyboard around, our character should move. Okay, so let's go ahead and drop our merged character into this room. We'll just put him here. And we really can just close everything else except for our merge controller. You know what? Let's do this a little bit differently. So we're going to actually assign the surfaces to the objects themselves that the sprites are coming from. All right, so I'm going to go to create. And I am going to create a surface here. I'm going to say surface, create, and we want some width. And I'm going to assign this surface to the size of our sprite's width and height. So I'm going to say sprite get width, and it's going to be our sprite index, and then sprite get height, sprite index. All right, so we've created a surface that is just going to be a 32 by 32 square. And whenever we create a surface, we want to always make sure that we delete it. So we're going to say surface free. And let's actually assign this to something. So we're going to say circle surf. And we are going to say circle surf. Okay. So now we've created our surface, and if anything happens, we will destroy it. Now let's go to our draw event, and we're going to first check to make sure that our surface exists. So we're going to say if our surface does not exist, we are going to create it. Actually, let's go ahead and change this. I'm just going to call this surf, because what we're going to do is, since the circle and the square are going to have the same, basically the same fundamental code, I'm just going to have a parent event or paste the code. We don't need to give them their own specific surface name. So we're just going to call it surf, and let's make sure we modify that in our delete, and same in our draw. Okay, so we've changed that to surf. And we're going to say if surface does not exist of surf, we're going to create that surface. And we're going to say sprite gets width of our sprite index, sprite gets height of our sprite index. Okay, so we want to make sure that before we do any sort of operations on our surface that we double check that it exists. Otherwise, if we try to draw to our surface or do any sort of manipulation to that surface, and that surface doesn't exist, our game will crash and we'll get an error. So first, let's just make sure that our surface exists. And if it doesn't exist, well, then we're going to create it. So we've created our surface. Now what we can do is we can say draw set target. Oops. Draw set surface set target. There it is. And for that parameter, all we need to do is pass in a surface. And whenever we set the target, we want to surface reset target. And then we are going to draw to our surface. So let's draw to our surface. All right, so we're going to say draw sprite. And we are going to draw our sprite index, our image index, and we're going to draw ourselves at 0, 0, okay? Because keep in mind that this surface is not the size of our room, the surface is the size of our sprite. So it's a 32 by 32. So on this surface that's a little square, we want to, since our sprite is also 32 by 32, we want to just draw at coordinate 0, and then we will draw our surface at the position of our sprite. Okay, so we're going to just draw our self at 0, 0. Now, I don't want to say draw self here, because draw self defaults to drawing at our x and y coordinate, and we don't want to do that because that will draw us outside of our surface. So we want to just make sure we draw sprite to 0, 0. So now we've drawn to that, and we've reset our target, and now we're going to draw our surface. So we're going to say draw surface, and we're going to say surf at x and y. So we're drawing our surface at our coordinate position rather than drawing our sprite at our coordinate position. Hopefully that makes sense. So let's go ahead and run it and double check that we see our blue circle where we should. Great, so there is our blue circle. Now I'm going to go ahead and create an object. I'm going to say obj parent. This is a pretty generic name, so hopefully in your game you'll be giving these objects a little bit more descriptive names. And I'm going to actually go ahead and remove all of this code that we just created, and I'm going to go ahead and put this in this parent object. So I'm going to get all the code from the create, the destroy, and the draw event. Because keep in mind, these circle and square objects are going to be functioning exactly the same. They just have different sprites. All right, and then let's go ahead and set our parent of this circle to obj parent, and same with square. Oops, let's say parent and give it that. Cool, 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 cool. All right, so we want to just work inside this parent object at this point now. So now if I just go ahead and hit play, circle and square should both be drawing properly on their own surfaces, little tiny square surfaces. Oops, we didn't get circle to show up. All right, so why is circle not showing up? And that's because we left this draw event here. So this draw event is overriding the parent's draw event, and since we have no code here, this doesn't get drawn. So let's go ahead and delete all of our events specific to the circle. And now the only events that it has are those events that it's inherited from its parent object. So if we run this one more time, we should see our circle and our square drawn properly. Perfect. All right, so we've just completed steps 1 and 2. We've created surfaces for them, and we've drawn our sprites to those surfaces. So now here comes the fun part. So I'm going to go to our merge controller, and I'm going to have to look at my notes for some of these things. So let me just go ahead and make sure everything looks good. So first thing that we want to do is we want to create a buffer for each of these sprites. So the main function that we will be using to allow this is a function in GameMaker that allows us to convert a surface to a buffer. Now keep in mind, let me go ahead and pull up a sprite so we can draw, and I can show you what exactly is happening here. So imagine that this is our surface, right? A series of pixels, and each one of these little checkered boxes is equivalent to a pixel. So here, if I say, this is a black pixel, this is a pink pixel, and this is a blue pixel. Okay, so I won't do all of them, but just to demonstrate what we have going on here is that we have a series of pixels, right? And if we look at any one of these pixels here on our surface that we have, each of these is going to be containing 4 bytes of data, and one of them is going to be for our red channel, our green channel, our blue channel, and our alpha channel. And all of these channels control the color of this sprite, and alpha obviously controls the opacity of this sprite. So these are all going to contain values between 0 and 255 to create the colors that we see. So when we convert our surface into a buffer, what we're really doing is we're going through each pixel of our surface, and we're saying, hey, what's the RGBA value of this? And we're going to store that into a buffer. And then we're going to go to the next pixel, and we're going to say, hey, what's the RGBA value of this pixel? We're going to store that into a buffer. And we're going to do that for every single pixel in the surface. So now that we have a data representation of what our surface, quote unquote, looks like. But it's going to be strictly just numbers stored in our buffer. So why are we doing that? Well, what we can do is if we have buffers containing numbers, we can go through, let's say we have a buffer for sprite A and a buffer for sprite B, we can go through each pixel of the buffers at the same time, take the values that are identical, take the indexes of each sprite buffer, and add the values of them together and average them out, and then store that as a new surface, and then store that surface as a new sprite. Right, I know, it's kind of a lot to think about, but hopefully as we go through it, we can explain it a little bit better and understand it a little bit better. So that being said, what we need to do is we need to convert our surfaces to buffers, all right? So let's first create our buffers. So I'm gonna say sprite 1 buffer equals buffer create. So we know that each surface is 32 by 32 because that's how big our sprites are, right? So we're gonna just default our buffer to 32 by 32. But keep in mind, as I mentioned before, our buffer is a series of data points, and each pixel on our surface holds 4 data points, right? R, G, B, and A for alpha, right? So we can't just store 32 Otherwise, we can't just store one. We have to store 4 pieces of data for every single pixel. So if our sprite is 32 by 32, well, we need to store 4 pieces of data for each of those pixels. So we need to actually create a buffer that is 4 times as long and 4 times as tall. Oh, and I misread this. So the first parameter in our buffer create is size. So normally we would say 32 by 32 is going to create our buffer, right? Because it's just a long data structure that holds a bunch of data. So we're going to say 32 by 32 would give us our sprite if we just wanted 1 value per pixel, but we want 4 values per pixel, so we're going to say 32 times 32 times 4. Sorry if that was confusing there for a second. So let's move on. All right, so the next thing we need to clarify is the buffer type. And what we want to say is this honestly is going to be pretty arbitrary for our example here, because we aren't dealing with we are dealing with fixed numbers and fixed sprite sizes and all of that stuff. So we could just assign this to buffer. I think static is fixed. Yeah, there it is. Buffer fixed, where that means the buffer itself is not going to change in size. We could set it to buffer grow. That way, if we put more data in that the buffer can handle, the buffer will grow and get larger. But for now, we're just going to say buffer fixed, because we always know that we're going to be dealing with 32 by 32 sprites. And our alignment is going to be 1. Now, what is this alignment? This alignment is just saying how many times do we want to move every time we read or write through the buffer, right? So every time we write to the buffer, we want to move only 1 over. Now, maybe there would be some circumstance where you would want to write and then move over 4 and leave 3 pieces of data available, or empty space available for more data. But for our example, we only want to write 1, and then we want to move to the next index in the buffer. And then we want to write 1 and move to the next. And when we read, we want to do the same thing there. So we just are going to set this to 1. And so we're going to do the same thing with sprite 2. I'm going to say, I guess I could just copy this over. And there we go. All right, so now we have 2 buffers. Now, the same thing we should do with surfaces or any other data structure is as soon as we create it, we should delete it. So we're going to say buffer delete sprite 1 buffer and buffer delete sprite 2 buffer. Okay, so doing our garbage collection here. Very important, because if we don't do that and we implement this into a larger game, we could introduce a memory leak, which would eventually slow our game and cause it to crash. And if you do it and then forget about it, it's really hard to track down some of these memory leaks. So it's very important that as soon as you create a data structure or a surface or anything that could potentially be volatile or that's not automatically going to be cleaned up in garbage collection, that you manually do it. Okay, so we've created our buffers and we have officially destroyed them. So now what we need to do is we need to read in these sprites of our sprites into the buffers that we want. So I'm going to just create a variable. I'm going to say obj1, and this is going to be equal to object circle. Oh, I did not spell circle right. Circle. All right, obj1 is equal to circle, and obj2 is equal to obj square. Okay, so this is just going to be for more dynamic, just to allow this code to be a little bit dynamic. All right, so now we've stored that. Let's go and add a step event. And what we want to do is first we're going to check to make sure that our objects exist before we try to do any sort of operation on them. So we're going to say if obj, if instance exists obj circle, and oh boy, and instance exists obj square, then we will proceed through our code. Yep. And then what we want to do is we want to make sure that each of those circles have sprites or surfaces. We know that they're going to have a sprite because we're manually assigning it on create. But we want to make sure that their surfaces have been created and exist. So what we want to say is if variable instance exists, and we're going to say obj1, and we want to check that they have a variable called surface, and variable instance exists obj2 surf. So this makes sure that the two objects we're working on even contain the variables called surf. Now we know that they do because we've created it, but again, if you want to try to make this as dynamic as possible, then it's always good to be checking for these things before we do any sort of operations on them, again, to prevent unnecessary crashes. I'll be covering this in detail in one of my upcoming videos called Clean Code and how to write clean code in GameMaker. But for now, just know that we want to check to make sure that our objects exist, that the object that we're trying to work on exists, and that that object contains the variable that we want. And I missed something here. I want to do obj1 and obj2. Again, we're making this dynamic so that we could just change these variables to whatever object we want to merge our sprites to. So we need to make sure we're operating on those variables, not the object itself. Okay, so we've checked that our object 1 and our object 2 exist. We have checked that they both have the variable called surface. We want to check if surface exists obj1.surf and surface exists obj2.surf. All right, so now we know that they have a surface variable and that those variables are assigned to a surface and that they have some value. Okay, so we've done all of our checking to make sure that we are good to keep moving. All right, let's make this a little bit larger. I should have done that from the beginning. And 1 second to drink some water. Okay, so now we have done both of these things. Okay, we could even go crazier and make sure that if buffer exists, what do we call it? Sprite1 buffer. Let's just call it buffer1. Since we're just keeping this nice and simple. Okay, so we say buffer1 and buffer2, so we want to make sure if buffer exists, buffer1, and buffer exists, buffer2. All right, so we have everything good to go. Everything is ready. Okay, so now that everything is ready, let's actually start doing our things. So the first thing we want to do is we want to read sprites into their respective buffers. All right, so first thing we're going to do, and I'm looking at my notes here, we just want to say, so this is what I was saying earlier, where we're just working around one function that GameMaker offers, which is converting a surface into a buffer. So this is pretty straightforward because GameMaker does this for us already. So we're going to say buffer get surface. And all we need to do is we need to pass in a couple variables. So we first want to pass in the buffer that we're going to save it to. So buffer1. We want to pass in the surface that we're going to save it. So we're going to say obj1.surface. The mode that we want to say is 0, offset 0, modulo 0. Now, I'm not going to explain these in this video just because we don't need to know what they are, but if you're interested, read the documentation on buffer get surface on GameMaker. They explain it. Modulo especially is going to be potentially valuable to you depending on how you plan on implementing this in your game. So I would definitely read up about the modulo, but for now, we don't really care about it. So we're going to do the same thing for object 2, and there it's surface and it's buffer. Okay, so we've read the sprites into the buffers. So we just did step 3, convert surfaces to buffers. Now what we need to do is we need to go through each buffer and combine the values in each of them into a new value, and then add that to a third buffer, okay? And I'll explain this more as we go through it. So I'm going to create temp buffer for storage. So I'm going to create a new buffer for storing this value. And we are going to say var temp buffer, let's give it something a little better name. Merge buffer equals buffer create. And again, for the sake of being dynamic and having this code be as reusable as possible, for the size, we're going to say buffer get size. And we're going to pass in one of these buffers, buffer 1 or 2. Okay, so we're going to say buffer 1. We're going to set our temporary merge buffer to the size of buffer 1. And actually, that reminds me, what we should do is we need to make sure, I'm sorry, I'm kind of all over the place when I think about these things. We'll finish this in just a second. But something you might be asking yourself right now as you look at this, and I'm talking about getting the buffer size, says, how do I know to get buffer size 1 or size of buffer 2? Well, we're assuming that the size of these sprites are the same. If they're not the same, this whole technique of doing these sprite merging becomes really, really complicated. So for the sake of this demo, we want to make sure that the size of these buffers are the same size, because if they aren't, then we shouldn't be doing this simple calculation on it. We should be doing a more complicated calculation that's going to determine where the buffer should line up and all of that stuff. And we don't want to do that for this. So we're going to say, we will also, before we get into this execution block here, as one of our other checks, we also want to make sure that our buffers are the same size. So we're going to say if buffer get size, buffer 1 is equal to buffer get size, buffer 2. All right. We'll come down here, we'll close this off, and let's indent this. All right, so now we have checked that the buffers are equal in size. And so now we can call buffer 1 or buffer 2 when getting the size of our new buffer, because it doesn't matter. They're going to be the same size. So we're just going to call buffer 1. On buffer type, we are going to say buffer fixed, and alignment is 1. And this is the same as everything we did in our create event, right? We want this third buffer to be the same essentially as buffer 1 and 2. All right, so now we've created this temporary buffer for storage. Now what we want to do is we want to iterate through these buffers and get their values out, do some math on it, and store that value into our new buffer, and then we will convert that new buffer into a sprite, okay? So we're going to say for var I equals 0, and we're going to say I less than buffer get size of our new merge buffer we just created. Oh, nope, just kidding. We want to do buffer 1. Now, theoretically, these are all the same size, but for the sake of semantics, we are iterating through our buffer 1 and buffer 2, so we should be looking at its size, not our merge buffer here. Just kind of a over picky technical distinction, but it is good to be as accurate as possible. So we are now going to iterate through our buffer. Now, keep in mind, though, well, we'll get to that point in just a second. All right, so next thing we want to do is we want to get the value from buffer 1 and buffer 2, right? So if we look back at ASprite here, oops, where'd you go, ASprite? Now let's draw up a different picture. Let's say, we're going to say this is buffer 1, and this is buffer 2, okay? So we have 2 buffers here, and each of these have some pixel values here, right? And what we want to do is we want to go through, we want to pull 1 pixel out of this buffer and pull 1 pixel out of this buffer, average their values together, and then store this new average, right? So let's say average, and then we want to store this new average in our temp buffer over here that we've created. All right, so we want to take all of these, we want to take the average of pixel 1 and pixel 2 and store that in that same index in our third buffer here. And then we want to do that for each pixel creating this new buffer. All right, hopefully that makes sense. So let's come back here. So we're going to iterate through our buffer, and we're going to say var. And now keep in mind, we are pulling R, G, B, and A values out of this surface, right? Because remember, like I said, every color just converts down to a RGBA value. So we're going to say var R1 is equal to buffer read, and we want to, what buffer are we pulling this from? We're going to say buffer 1, and we want to specify the type of data that we're going to be pulling from this buffer. And we're going to say buffer underscore U8, and this stands for an unsigned integer of 8 bytes. So just because we're storing from 0 to 255, not a very large integer, that just is going to default to a U8 value. So we're going to say, okay, well that's our R1. What we want to do is we want to say var R2 is going to be equal to buffer read, and we want to read the pixel from buffer 2, and again that's going to be of the same type. And what we want to do is we want to say var R3, or let's say R average is equal to R1 plus R2 divided by 2. Okay, so all we're doing is we're taking R1, which is going to be some value, I don't know, if it's a red, like let's go back to ASprite here, right? Let's pull this yellow. Let's assume the first pixel in buffer 1 is yellow. Well, we know that yellow has an R value of 251, okay? So let's just pretend that this is going to be 251. And let's say the next pixel is going to be blue, is this blue color, right, in our buffer 2. The first pixel in buffer 2 is this. Well, we know that's going to be some 91 color. So we're going to say 91. So we're going to average these out together, and that's going to be what? 251 plus 91 is equal to 342, and then we're going to divide that by 2, which is going to be 17.6, right? Something like that. Okay? And then what we want to do is we want to store that red value back into the buffer and say, hey, here's our new red value. This is the red value of the two sprites merged together. Now, one thing to keep in mind is if there's no pixel there, right, let's say we're iterating through our surface and it just happens to be an empty surface, it's going to default to 0, 0, 0, 0, which is going to be all black. But it's going to have an alpha of 0 also, so it's going to be completely transparent. All right, so we have successfully covered the theory of what's going on here. Let's now take our averaged value. Let's say we're going to write this new value to our buffer. So we're going to say buffer write, and we want to say this is going to be written to our merge buffer. Oh, not marge buffer, but our merge buffer. And the type that we are writing, well, we are writing an unsigned 8 integer, just the same as we were reading here. And the value that we want to write here is our average. And for the sake of consistency, I'll put an underscore before my temp. You don't have to do this, but I like to do this to help distinguish which variables are just inside this scope. Okay, and now we want to write that value there. Okay, so we did it. We just successfully wrote our red value to the buffer. Now, what do we do next? Well, we do the same thing for green, blue, and alpha. So I'm going to take this, I'm going to copy this, I'm going to paste. That's for RGBA. And we're going to just do the same thing. So I'm just going to change some variable names. I'm going to say this is G1, this is G average, G1, G1. We want to read from the buffer. So keep in mind the way buffers work is once we read, it automatically moves to the next index. So we don't have to specify any sort of index increment here to say, hey, get the next value, because we've already read from the buffer, and that buffer alignment that we set up in our create event, this 1 here, tells us that every time we read or write from a buffer, automatically move to the next index of, in this case, an increment of 1. So we don't have to specify any sort of movement of our index. We just have to say, all right, we want to read from the buffer again. So we're going to read from the buffer again, and we want to write into our new buffer G average. And we want to do the same thing for blue. So let's come through here, blue, blue, blue. And then we want to do the same thing for alpha. So this is going to be A, and A. So the first thing, one of the things I want to point out is that this is looking great, we're doing good, but the next thing, or one of the things that we need to pay attention to is that with each iteration of our for loop here, we are actually plucking out 4 pieces of data from each buffer. So when we iterate through this buffer, we don't want to iterate through the whole buffer because we're going to hit an index out of bounds error. We want to only iterate through a quarter of the buffer because each iteration of this loop is going to pull 4 pieces of data out of that buffer. So this is a very important distinction to make because otherwise we're going to get some errors later on, and we only want to iterate through it a quarter of the time. So now we have successfully taken all of the pixels out of surface 1 and all of the pixel values out of surface 2. We've averaged them together, and then we've written them to a new buffer. Okay, so what have we done? We've done steps 1, 2, 3, and 4. So we just finished step 4, which is combine the buffers. Now what we want to do is we want to, so let's say combine buffer values, and now we want to say convert buffer to sprite. Well, unfortunately, there is no way for us to store a buffer as a sprite. GameMaker doesn't allow it, but it allows us to store it to a surface. The same way that we were able to get from a surface, we can store it to a surface. So let's go ahead and create a new surface. We're going to say merge surf equals surface create, and the width is going to be, let's say, surface get width. That does exist, great. And we're just going to get the width of some object surface here. So obj1.surf. And we're going to say surface get height obj1.surf also. Okay, let's go ahead, and we've created our temporary surface. Now we need to write our new merged buffer into our merged surface. So we're going to say buffer set surface, and now we need to specify the buffer. So it's going to be merge buffer into our merge surface, and then our mode is going to be 0, 0, 0, and this is the same as our buffer get surface up here. All right, so now we have converted the buffer into a surface. Now let's convert that surface into a sprite. And so we're going to say var merge sprite equals sprite create from surface. So this is built into GameMaker as well and allows us to take a surface and convert it into a sprite. So we're going to say this is going to be our merge surface. So the x and y, I want to say this is 0, 0. Our width is going to be our sprite get width of obj1.sprite index. And then we're going to say for our width, it's going to be sprite get width of obj1.sprite index. All right, I'm going to do some weird formatting stuff just to keep this all on the screen so that we don't have to scroll over every single time that we want to see it. So here's our width, here's our height. Remove back, do we want, so basically what it'll do is it'll check for the top left pixel of our surface, and it'll say this color is going to be the back, and if we say remove back, it'll make every pixel that's the color transparent, and it'll make, but it'll keep every other pixel the same. If we say don't remove back, it'll just keep that in there. So let's say that your background in your game is black, and you want to create a sprite from this surface, but you want black to not be part of this new sprite. You would say remove back equals true. It would find every pixel in that surface that is the same color as the top left pixel, and it would remove it from this sprite. For this situation, we don't really care. I think we'll say yes, because we do want a transparent back. But we are going to say, the reason I'm going to say false here is because our square extends to the top left corner, we might accidentally interpret that red as our background, and then it might remove that. So for the sake of this video and not making any dumb mistakes, we're going to say false for now. For smoothing, we're going to say false, and for origin, we're going to say 0 and 0. And this is the sprite origin, so pretty straightforward. And we're going to close that out. All right. So now we have created our merge sprite. Let's assign that sprite to our object. So we're going to say if instance, so let's actually come back to our create event. We're going to say obj3 equals obj merged, right? This is the object that we want to store the merged sprite into. And we're going to say if instance exists of obj3, we want to do this, and we're going to say obj3.sprite index equals merge sprite. I hope this works. I already see a potential problem, but so we are trying to read outside of the buffer, returning 0, line 20, buffer read. So R1. Well, first thing we want to do is, the first thing I was going to say before we got that error is we don't want to do this every single step. So we are going to trigger this on like a keyboard press. So we're going to say if keyboard check pressed, let's just say VK space. You could set this to any sort of trigger event, but I'm going to set this to space just for our testing. So that way it's not happening every frame that we're trying to create this and merge these together. We don't need to do that. Let's run it again and just see what happens. Obviously it's not going to change anything that happened here. Oh, you know what was happening is the step event was triggering before before object circle and object square was created. So it was trying to read all of that stuff, but nothing had been instantiated yet. So makes sense that we threw an error. But now that we add our trigger press event, we don't get that error anymore. So again, it's important to make sure that you have this set up in the right order, otherwise GameMaker will freak out. So I press space, and what do you know? We have a merged sprite. Now you'll look at these and you'll say, okay, this is kind of weird looking, right? Like this is not quite what I was thinking of when I wanted to merge these two sprites. And that's because we're averaging the values that we take. So if we take blue, or let's say like this top left corner right here. I know it's kind of small to look at, but you take a look at this top left corner, right, where it's just like a dark red corner of the square, and you say, okay, I mean, sure, it's a merge, but it's not quite what I wanted. Well, what's happening is we're taking this red value from our square, and we're averaging it with this nothing value in our top left corner of our circle, and that's just basically averaging our color with zeros. So we just get a darker version of our color. So that's not quite what we want. So we can change this pretty easily. Instead of getting our average, let's just say our max, and we're going to say we want to get the max value of R1 and R2, and that's going to be the new color that we store. So let's go ahead and actually do that for all of them. So we're going to say Gmax, I'm going to say Bmax, and we're going to say Amax. And then we're going to change this to, instead of averaging them, we are going to take the max. All right, so let's run it again. Let's see what this looks like now. Instead of averaging it, we take the max value of either of them. So I hit space, and hey, what do you know? So now we get this full red color here, and we get this weird pink color. Oop, I just tried hitting space again, and it's freaking out because we haven't reset where the buffer is. Yeah, let's do that real quick. We can, after all of this, we're going to say buffer seek. Then we're going to say buffer1, buffer seek start. So that just says, hey, put the pointer of the buffer back at the beginning, and we're going to say an offset of 0. And we're going to do that for buffer seek. Buffer2, buffer seek start, and 0. And then we need to make sure we say buffer delete our merge buffer right? Delete everything and surface free our merge surface. Remember, clean up your garbage. Don't let it just sit there and clog up your sprite. Oh, also, we need to delete this sprite too. So we're going to say sprite delete. And we're going to say merge sprites. Almost forgot all of this. Very important steps in any sort of project that you do all of this. Okay, like I said, I think I'm going to end the video here. It is sufficiently long enough. Let me know if you come up with a cool way to merge these sprites, if you find a more accurate way to get kind of the true values of each of them into the final output. Thank you guys so much for stopping by and watching this and hanging out with me for another, I don't know, 45-minute video. Again, how long are we going on? There's no way for me to check the time right now. But thanks for hanging out, guys. If you're interested in seeing more, please check out my other videos. Like and subscribe, share with people that you know. Check out my Twitter. I'm posting some really cool stuff on there. And if you really like what I do, always feel free to support me on Itch by buying an asset, or on Coffee by buying me a coffee. I could always use another cup of coffee. Thanks so much, guys. I'll see you next time.